Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at solving a system of linear equations using the substitution method. Before we get started, each equation represents a line, and when we have two lines to work with, there's really three ways they can interact. So I've got the three scenarios listed at the top that will produce one solution, no solutions, and infinitely many solutions. The first case is where we have the second line crossing the first line exactly one time. And so that point where they cross is the single solution. Now, what kind of line would I draw if there were no solutions? That's going to be a line that's parallel to the first line, meaning that they will never cross. This is what we call an inconsistent system, and it has no solution. For infinitely many solutions, what has to happen is that the two lines are actually the same, and they coincide at every point on the line, which is infinitely many of them. So we call this a dependent system because the first equation and the second equation are the same. They depend on each other. All right. We're going to use the substitution method to solve these first two. And the idea for the substitution method is we want to solve one of the equations for one variable in terms of the other, and then we'll substitute that expression into the other equation. So when I look at this system of equations, 3x plus 4y equals 5, x minus 5y equals 27, I can see that I have a plain variable of x, and that's going to be easy to isolate by itself. I can do that by adding 5y to the other side of the equation, so that second equation becomes equivalent to x equals 5y plus 27. And what I want to do is I want to take that equation, which says that x is the same as 5y plus 27, and I want to put it in for x in the other equation, since it's the same as 5y plus 27. That's going to give me 3 times 5y plus 27 plus 4y equals 5. Again, just replacing x by that expression. Now I have a single equation with just one variable, y, and I already know how to solve that type. I'll begin by distributing the 3, 15y plus 81 plus 4y equals 5. I've got some like terms to combine. I can also move the 81 to the other side of the equation by subtracting it. That gives me 19y equals negative 76. And when I divide both sides of this equation by 19, I get y equals negative 4. So one thing we want to be careful of is that we're used to stopping once we've found that one solution, but I need an x and a y here, so I really only have half the solution. The way I'm going to get the rest is by bringing that back to the equation that I used to make the substitution. I know that x is the same as 5y plus 27, so I can say that x is the same as 5 times negative 4 plus 27, or negative 20 plus 27, or 7. Now I've got my x and y. That tells me that my solution is the ordered pair 7, negative 4. Now I can check this by plugging into the other equation. If I put in 7 for x in the first equation and negative 4 for y, I need to see if that's equal to 5. And in this case, it works out because 3 times 7 is 21, 4 times negative 4 is negative 16, and 21 minus 16 is 5. So our solution is 7, negative 4. Let's take a look at one more that we'll solve by substitution, and this one's really ready to go. I've got y isolated here. I know that y is the same as 3x minus 4, so I can take that and substitute it for y in the other equation. When I make that substitution, I get 6x minus 2 times 3x minus 4 equals 5. Let's solve. Distribute the 2. We get 6x minus 6x plus 8 equals 5. And when I go to combine these like terms, 6x minus 6x is 0. And so the variable term disappears. When that happens, we've got something unique. We've got a case where it's either going to be inconsistent with no solution or dependent with infinitely many solutions. And you want to take a look at the equation you have. Is this equation true or false? Does 8 equal 5? No, that's a false statement. That means that there are no solutions, because no matter what we put in for x and y, we can never make 8 equal to 5. And we say that this system is inconsistent. Now, if we had 8 equals 8, that's true all the time, no matter what x and y are, and that would be the kind that's called dependent. We'll take a look at that type when we solve with our second method called the addition method or the elimination method, and we'll do that one in the next video.